So now, what you're looking at up here, it just looks like kind of a mishmash. But really, think about it, when we go through photosynthesis, you're taking light energy, plants do this, and then they change it into chemical energy, they store it away in glucose. Okay? And that takes place in the chloroplast. But if you had like Fruity Pebbles this morning, right now, bless you, your body is taking your Fruity Pebbles, your food energy, and it's converting it over to chemical energy, and that chemical energy is in ATP. Now, we've been talking about ATP for a little while. Check out this bottle. I kind of made it up. I put food coloring and water in it.
Read that bottle.
Stuff in it. Now, there's 8.8 ounces. At any one time in our body, you're going to find this much ATP in your body. Okay, that's the energy. But throughout the day, in a 24-hour period, we all make our body weight in ATP. So this stuff is always going on, and it's going through cellular respiration so we can make the ATP. But we got to be eating and having food energy to have this happen. Now, the organelle where it takes place is the mitochondria. That's important. Majority of it takes place here in the mitochondria. Very, very important question. Okay, any questions on that? Okay, so we're only going to get through the first step today. Only going to get through the first step, which is not going to take long at all. So here it is. This is your first stage. Now, again, you're in biology. Lots of big words, confusing. Looks like glycolysis, doesn't it? It's actually glycolysis. And if you break it, the word here, this means to break or split, and this means sugar or glucose. So we just put sugar. So you're breaking sugar. So right now your body's producing this glucose, and you're getting it from your food, and it's breaking it down, trying to get some ATP out of it. Now leave a little space right here because I want to come back and show you an easy way to remember what's happening here. Remember, this is the first of 3. I can tell you last year my notes were like 20 minutes long on this day. I've got it down to 7. That's why I'm recording a new video, making it more improved. Please take notes. It's so important. And don't be scared to ask questions. Okay, so here's some things about glycolysis. Happens in the cytoplasm. Remember, I just told you it happens in the mitochondria. Well, this step actually takes place right here. See this fine picture of a mitochondria? That's the powerhouse of the cell. You heard that forever and ever and ever. That's about as deep as you ever get in cellular respiration. Oh, this is the powerhouse. This is where CR takes place. CR, so I don't have to write cellular respiration, right? So glycolysis takes place out here, outside it, in the cytoplasm of the cell. You can't see the cell because the picture's cut off, but this is where it's happening, really close to the mitochondria in the cytoplasm. Now, provides really quick energy. Now, this is helpful if you're being chased by a serial killer who's got a sword, and he happens to be a really good runner, but you're scared, you're motivated, you go. There's going to come a point where you're going to run so low on oxygen that you're going to have to stop. But let's say you can outrun this guy because you're extremely motivated, but he's not stopping. He keeps coming after you. Finally, you look back, and he's like, so you're like, okay, I'll take a break. So you stop, he stops, but he comes after you right away. Well, you can't run, you're dying. And then you take off running again. That's what is helping you. Okay, it doesn't require oxygen. This just provides quick energy. So you could stop breathing. This would keep taking place outside here. It's the other processes that would stop, and then you would not make it. Okay, you get the idea. So when you need emergency energy, this thing does it. Now I think it can produce thousands and thousands and thousands and thousands of ATP every second. That's a lot when you start taking all the mitochondria you got in your body. That's a lot. It's still not enough to supply you because you need more. But keep this in mind, this gives you just a little bit. Now, it says it takes 2 ATPs and it makes 4 ATPs out of it. So remember, ATP is energy. So it actually has to spend 2 ATPs to get the process going. And look what it gets in return. It gets 4 ATPs back. Do you guys know the difference between gross and net? gross and net. It produces 4 ATPs gross, but what's the net gain?
6.
How much?
2.
2. Bless you. Because it spent 2 of the ATPs, but it's made 4, so it's replaced them, and now it's got 2 ATPs in the bank. Matter of fact, you need to write that up there. It makes 2 ATP. This is going to be like the only number that you're going to be required to know. Okay, so it takes one glucose molecule and turns it into something called pyruvate. That's all you'll need to know about pyruvate, is that that's what glucose is split into. That's all you need to know. That's all you need to know. Okay, questions so far? Do you guys remember when you were a little kid, mom, dad, grandma, grandpa, whatever, gave you a quarter for a gumball, a gumball machine?
Yeah.
It's pretty good times when you're a little kid. Shoot, every once in a while, I'll buy one. You never grow out of it, I don't think. Okay, now what's that got to do with this? Okay, now listen really carefully what I'm going to tell you. Let's say you could go to Strack. I think they have some gumball machines. But you could put in a bigger gumball, actually a bigger gumball than what they have in there. You could put it in. You put in 2 quarters. You turn the machine. You turn the little knob. And then what happens is it kicks out 2 gumballs, and then it spits back 4 quarters. Wouldn't you like that?
Yeah.
That'd be a good deal, wouldn't it? All you're doing is trading off a bigger gumball and 2 quarters, and you're getting back 2 smaller ones and 4 quarters.
So you could get more.
So then you could probably get more. Very nice. He's seeing it. You're seeing it. Okay? That's the analogy I want to use. I didn't use this last year. I just figured this one out. This is cool. Okay? Now, look up here. Remember, if you get confused, you always go back to right here. Here's what's happening. Glycolysis. You're taking 1 glucose and you're adding how many ATP? 2. So you add 2 ATP. That's energy, right? You're adding, it's like juicing it up. And then you're going to go through glycolysis right there. And then you're going to end up with 2 pyruvate. Remember, you don't have to know anything other than it's pyruvate, and that's what glucose turns into. And then how many ATP are given off? 4. Again, that's the numbers can be confusing. Okay. Now this is going to go to step 2. Whatever that is tomorrow. Step 2. That's what we're going to talk about. Step 2. Have you ever seen little babies?
Yeah.
Good. That's nice. Have you ever seen toddlers play like with different shaped blocks? And they try to fit the block in the right shaped hole? And so a little baby will take a square block and they're trying to fit it into a round hole. And they get aggravated, so they start pounding on it.
Yeah.
And then eventually they figure out, oh, I didn't go in there. And then they'll go over here and they'll pop it in. I want you to think of this. Glucose, let's just say it has a square shape. In order to get into step 2, it's got to have a square shape or a round shape. It won't fit. It won't fit. So Mother Nature puts it through this, changes it to this. Guess what? Pyruvate has a round shape. And so that's how Mother Nature works around it. It breaks it down, switches it up. Okay? Square peg can't go into a round hole. So Mother Nature says, oh yeah, okay. Well, we got to reconstruct it, so let's give it a little energy. Let's do a little work. Okay, now we got 2 pyruvates. All right. Now, I'm going to erase this. Now watch this. Here's another way of thinking about it. Can you remember glucose? What is the chemical formula? This class is good with it. It's C what? H12O6.
6.
Yeah, 6. So it has 6 carbons, right? Now watch. You're going to see this sometimes. Glucose might have 6, usually black colored dots for carbon. So there's 6. And we're just going to put glucose up there. right? That's muscle food. That's our energy source. It's going to go through glycolysis, and then it's going to turn into pyruvate. Remember that word, pyruvate. You just need to know that's what glucose turns into. But it doesn't look like glucose, because remember, it's got a different shape. Matter of fact, it looks like this. Here's one. Here's another. You see what's happened? It's broken it down. Now, you guys know this already. What did I have to add to get the process going?
ATP.
To ATP. But when it goes through the system now, it turns into ADP. Remember? Full battery, drain battery. Okay? And then here I'm going to put 4-ADP, and then it's going to turn into what?
4.
4 what?
ATP.
ATP. See, dead battery gets recharged and made, then it makes 4 ATP. Now, if you're an athlete, you want this. If you're a basketball player doing suicides and them legs are burning, and you stop, your legs stop burning because your body replenishes this partially through this. And so after a minute, you're ready to do another suicide. Or, I don't know what basketball coaches here, they're probably not waiting a minute, right? They're probably going faster than that. I tell you what, suicides, they suck. Wow. They're rough. But anyway, look at it. Here's another way to picture it. Get it? Another way to picture it. Okay, any questions on glycolysis?